Hi folks, I'm so happy that you have joined us for today's mathematics lesson. So let's take a look at piecewise functions today. I'm going to try to show you the easiest way to graph piecewise functions. So if we want to graph a piecewise function, let's just say it's defined like this. The easiest method is just to plot some points. So we begin by graphing the left-hand function. So just substitute in a 1, and you get 2 times 1 plus 1, so that'll be 3. Substitute in a number less than 1, so maybe we'll do it 0. 0 gives me 1. Plug in another number. Substitute in -1. -2 plus 1 is -1. So those are our 3 dots, but what you'll notice is that this says x is less than 1, but I plugged in a 1. I didn't make a mistake, I just need to clarify that that is an open dot. So when you go down here and plot your points, you're going to do an open dot there. Okay? However, in my notes it says hollow, so there you go. However, all the other dots are solid. Okay, this is the only part of this problem in its entirety that it will have an open dot. Okay, so then we connect it with like a nice straight line. We go ahead and shoot that arrow down there to the bottom left, so we connect the dots. Make sure you don't go to the right. You can't go to the right because on the right side the function is going to have a different behavior. So on the right side we'll substitute in 1, and this time we'll get 5 minus 1 or 4. And we'll plug in another number, 2. 5 minus 2 is 3. And we'll substitute in another number, maybe 3. 5 minus 3 is 2. So these points I will go ahead and plug in. Notice that this time it is a solid dot. Now why is it solid? Now the reason that it's solid is because that says greater than or equal to 1, so it is allowed to be plugged in. Okay? That is the function that we want. So this should indeed be a solid dot. All of these are solid dots. Okay? Alright, and then you just connect your dots like normal. Maybe add an arrow to let us know that the function keeps on going forever and ever. Amen. Please pause the video and give this one a shot. When I look at this one, this first piece, I see that it says the slope is 1, but I see that at -1, I basically need to substitute in -1, right? So substituting in -1, I get 3. At -1, I should get 3, and that should be an open dot. Then I'll substitute in another number, a number less than -1, so -2. I'm sorry, I didn't mean to write that 3, so -2 goes in and I get 2. So -2, 2, and it's a solid dot. And I know what the slope is, it's down 1 over 1. Well, it's up 1, right 1, or down 1, left 1, right? So there is the left side of our piecewise function. The next piece, we're going to substitute in -1, but this time we're going to get 3, and we substitute in, I'll go ahead and put in +1. Still get 3 because this function right here is just a constant function. It's saying that the y value is always 3 between -1 and +1. In this case, though, it says that both dots should be filled in. So if I already have an open dot, what do? Well, I just fill it in. You don't have something that is open and closed. It is now officially closed. Okay, so I don't want to see any of this. Don't do that. Okay, that's something new that you created. So let's just write a note somewhere that a solid dot overrides a hollow dot. Okay, so let's keep rolling. On the next piece, we'd substitute in 1. 5 minus 2 is 3. And then we would substitute in a number bigger than 1, greater than 1. So 2, 5 minus 4. So we're going to put these points in. The first point it says should be open, 1 3. But we already have a solid dot at 1 3. So we don't open it up all of a sudden. Okay, we keep it closed. And then we're going to go over to 2 1. And then we will connect those two dots with a nice straight line. And there you have it, folks. That's your trapezoidal looking graph. It's a piecewise function. All right? It doesn't happen often, but sometimes it's easier to graph on a TI-84. I'm going to show you how to do that. So we're going to go to our y equals and type in 2x plus 1. And then we will type in the domain. The domain can be typed in with parentheses. X, second test, scroll down to the less than sign, and then we can add another function to that. So instead of 2x plus 1, we're going to do x squared, so x squared. And then we'll put in parentheses, x is, I forgot to say x, so x is greater than or equal to 1. And we'll see what the calculator thinks about that. Well, I have my linear. Okay, I messed up somewhere, didn't I? So let's take a look at that. Okay. So it looks like to me, maybe this is reading something incorrectly right there. So maybe I didn't communicate that the right way the first time around. There you go. That's a lot better. Okay, so there was, if you have a binomial, that's something to really pick up on right now. If you have a binomial, you will want to put that in parentheses before your domain. And that's what I had messed up. Okay, so notice in your calculator that that it doesn't give you an open dot. Now there is a way to do an open dot on like an application like Desmos, but not on your TI-84. So what you're going to have to do to find out which one is open and closed is just by hitting trace. If you push trace 1, enter, notice that that one down there is the point, 1 1. So that one's filled in, and immediately to the left of that at 0.99, that's that one up there. So you're going to leave an open dot at the top one. So tell you what I'll do is I'll just draw in this figure right here that this is an open dot. And maybe even I'll just close this one. I don't necessarily have to do that, but that'll let us know. It'll clearly communicate, I guess, what the solid and hollow dots are. And our last example, I'm just going to go back and edit this, and it says x plus 2, and then it says that x is less than 2, and then it says x squared where x is greater than or equal to 2. So we'll hit graph, and you notice that this time they are connected. Now, is there still a hole there? Well, I'm not going to be able to see it unless I type in that breaking point. So type in that breaking point at 2. At 2 you get 4, and there is no breaking point there, okay? And another way to test that is just to type in 2 here, you'll get 4, and type in 2 here, and you'll get 4. Now this one's technically open and then closed, but remember that the closed dot will override the hollow dot. Okay, so that's how you do it in a calculator, and also how you do piecewise functions by hand. I hope that was an enjoyable experience for you, and I hope you learned a lot. Take care.